we're going to focus in a little closer on this triangle just so we can see what's going on. If we look here, we see the triangle with its base of 0.25, its unknown rise, that's going to be the change in volume. This is our 0.25 unit change in the diameter. Now, if we're looking at the point where the diameter is 15, then we have the diameter volume coordinates 15 and 6.75. The 6.75 we get just by plugging the 15 in for the diameter into the y equals ax cubed, which is a 0.002x cubed function here. And we get 6.75 for the volume. That's not real relevant, but that is what we get. Now, we observe that the slope at this instantaneous point here, at this specific diameter, is 1.35. That's the slope of this purple line. Now, I've exaggerated the curvature of the actual graph. This is the actual graph here, running along the green line. And it doesn't curve nearly that much over an interval of 0.25 near x equals 15. However, to show the principle here, we see that we have a slope here between the two actual graph points. And what we're trying to find is maybe the coordinates of this point, or at least the rise here. Remember, the original question was to find the change in volume. How much more salt, sugar, whatever do we have to add to increase the diameter by 0.25 units? Okay, so we at least want to find the rise here, from which, if we wish, we can add the rise to the volume to get the volume at this diameter here at 15.25. Now, the point is that this is the actual slope at this instant, and this slope, if we have a small interval, 0.25 here, that this slope is going to be near this slope. Not exactly equal to it, but very near. And as this interval gets smaller and smaller, it's going to be nearer and nearer. Once again, for this specific example, for the numbers we're given, it'll be much nearer than it looks here. We've exaggerated the difference just to show that there is a difference. In any case, the fact that this slope is near 1.35 and we have a run of 0.25 allows us to easily calculate the rise. Since the rise over the run equals the slope, the rise is going to be the slope times the run. 1.35 times 0.25, that's going to be a quarter of 1.35, roughly about 0.34 tablespoons of salt, sugar, or whatever the substance is, needs to be added to increase the diameter 0.25 units when the diameter is 15 units. If we had a diameter different than 15 units, we could simply calculate the y prime at that point. For example, if we want to know how much we have to add when the diameter is 20. We put 20 in here, we get a slope, and we multiply that by our run. Say the run is still 0.25, we would get a different result here for the volume that we'd have to add to increase the diameter when the diameter is 20. To increase the diameter by 0.25 at the point when the diameter is 20. The bigger the diameter, the bigger this is going to be, and the more stuff we're going to have to add.